Our universe is billions of light-years vast and continues to stretch with an accelerating rate. Light is considered to be the fastest in the universe, and that too would take millions of years just to travel between two galaxies. So is there anything out there which we don't know about which could cover this stretch in mere minutes? This is where the concept of wormholes comes in. To understand what a wormhole is, we first need to understand the concept of spacetime. Spacetime is a four-dimensional fabric that combines space and time into a single entity. According to Einstein's theory of general relativity, spacetime can be warped by the presence of massive objects like stars and black holes. A wormhole is a hypothetical tunnel or shortcut through spacetime that would allow us to travel vast distances in a short amount of time. Imagine spacetime as a sheet of paper, and a wormhole as a hole punched through the paper that connects 2 points on the sheet. Now, you might be wondering how wormholes are created. The answer lies in the warping of spacetime. According to the theory, if spacetime can be warped enough to create a black hole, it should also be possible to create a bridge between 2 points in spacetime, effectively creating a shortcut through space. So, how exactly does a wormhole work? Let's imagine that you're traveling through space and you want to get from point A to point B, but the distance between those 2 points is so vast that it would take you thousands or even millions of years to get there. With a wormhole, you could create a shortcut that would allow you to travel from point A to point B in a fraction of the time. But there's a catch. Wormholes are incredibly unstable and difficult to create. In order to create a stable wormhole, you would need to find a way to control the amount of negative energy inside it. Negative energy is a hypothetical form of energy that would be required to keep the wormhole from collapsing in on itself. Unfortunately, we don't know how to create or control negative energy yet, so for now, wormholes remain a purely theoretical concept. Now, you might be thinking that if wormholes are only theoretical objects, how do we know they exist? The truth is that we don't have any direct evidence of wormholes yet. However, we do have indirect evidence that suggests they might be possible. For example, scientists have observed the behavior of subatomic particles that seem to communicate with each other instantaneously, even when they're separated by vast distances. This phenomenon, known as quantum entanglement, suggests that there might be some kind of hidden connection between particles that we don't yet understand. Another piece of indirect evidence for wormholes comes from observations of black holes. When matter falls into a black hole, it gets compressed into a singularity, a point of infinite density and zero volume. However, some scientists believe that instead of getting crushed into a singularity, matter might instead fall into a wormhole and emerge somewhere else in the universe. So, why are wormholes so fascinating to scientists? One reason is that they could potentially be used for space travel. One idea is to use wormholes to create spacetime tunnels that could transport spacecraft from one point in spacetime to another. This could potentially allow us to explore distant planets and even other galaxies. Just imagine being able to travel to other galaxies in a matter of minutes instead of millions of years. This would allow us to explore the mysteries of the universe in ways we can't even imagine. This shows how vast the universe is, carrying billions of years of history with it and mysteries unsolved which would put us in question of our reality. If you feel overwhelmed, remember even our Earth, where all of mankind's history has happened, is not even a dust particle compared to the size of our universe.